2014, the questions were 14 to 19 and 33 to 35. So number 14 says, which system of equations has the same solution as the system below? We have 2x plus 2y equals 16 and 3x minus y equals 4. So if we start with option 1, the 2x plus 2y equals 16, okay, so that matches up, so that's good. But the next one, 6x minus 2y equals 4, related to this second equation, it appears that we're multiplying everything by 2. However, they never multiplied the 4 by 2. So it can't be number 1. So if we go on to number 2, it says 2x plus 2y equals 16, so that looks good. In the 6x minus 2y equals 8, this time they did multiply everything in the second equation by 2, and so it ends up being that choice 2 is your answer. Okay, so for number 15, the table below represents the function f. The equation that represents this function is one of the following. So what I would suggest doing is just start with your first answer and see if it checks out. Remember, whenever you see f of x, so when you see this f of x, it's always going to equal just y. So don't let that f of x, confuse you or anything like that. So in the table, it's saying, with this function, if we put 3 into x, the y value should be 9. So if we check out number 1, 3 raised to a power of 3, so if we're doing the work over here, we have 3 to a power of 3, well, that would equal 27. So since that won't equal our 9, it cannot be choice 1. Let's move on to choice 2. In this equation, it says, take your x and multiply it by 3. Okay, so we start with 3. So 3 times 3 equals 9. Okay, so we're good so far. Let's try 4. If we take our 3 and multiply it by our x of 4, we'll get 12. But they say that we end up getting 17, so it can't be choice 2. Let's move on to choice 3. 2 to the power of x plus 1. Okay, so if we say, hold on, let's get rid of some of this stuff so we have room. And the function says take 2, raise it to a power of your x, so in this case 3, and then add 1. So that gives us 8 plus 1, which is 9. Okay, so the first one works. How about when we have x equal to 4? So 2 to the 4th plus 1. Okay, well that would be 16 plus 1, so that actually gives you 17, so that's good. If we keep moving, 2 to the 6th is 64. If we add 1, that gives us 65. And if I kept going, I'd find out that 2 to the 7th plus 1 is 129, and 2 to the 8 plus 1 is 257. So that means that choice 3 is your answer. If you wanted to double check and you wanted to say, okay, does choice 4 even work? We could say, okay, well 2 times x plus 3, start with your x value of 3, 2 times 3 is 6, plus 3, okay, that works, 9. 2 times 4 is 8, plus 3 does not give you 17, so again, choice 4 would not work. Okay, let's move on to number 16. So number 16 says that John has 4 more nickels than dimes in his pocket for a total of 125. Okay, so that's important. The total is 125. Let's see if I can underline that. Which equation could be used to determine the number of dimes x in his pocket? So from his last statement it says x equals the number of dimes. So we don't even need to come up with a let statement. They told us what x equals. So if x equals dimes, and he has 4 more nickels than dimes in his pocket, that means, remember, more than would mean we're adding. So we're going to take x, which is the number of dimes, we're going to add 4. That's going to equal the number of nickels. Okay, so dimes we know are worth 10 cents. So 0.10 would be referring to the dimes. And nickels are worth 5 cents. And that's going to be 0.05. So if we look here, remember, the whole thing that you have to remember from here is your cost times your quantity will always equal your total. Remember, they said our total was 125. So the cost of a dime is 10 cents. So we have to find the equation that says, 10 cents times x, 0.10 times x, which means it can't be this first one. Okay, so it can't be number 1. Number 2, I do see 0.10 times x. That's good so far. And then we're going to add it to 5 cents, 0.05 times the number of nickels, which is x plus 4, equals your total. So in this case, number 2 is the right choice. Okay, number 17. If f of x, okay, now remember, you see f of x, you can just think in your head, this really just means y. So think of it as y equals 1/3 x plus 9. Which statement is always true? Okay, you could do a couple things here. You could use your graphing calculator and look at the graph of this. Or if you remember, look, this is a linear function where 9 is your y-intercept b, and the 1/3, this right here, is your slope m. So if you wanted to just draw a sketch of it, you would start right here, roughly about where, let's call this 9. Okay, so this is 9. And your slope is up in the positive direction, right? You rise 1, then you're going to run 3 in the positive direction, up 1/3, and then you can also go down 1 and to the left 3. So we have something like this, okay? That's just a rough sketch of it. So now if you look at our different options, it says f of x. Remember, f of x is just y. So it's saying, which statement is always true? Is your y values, are they always less than 0? Well, if we look, no, we have y values that are going to be greater than 0. So it can't be choice 1. Number 2 says, are your y values always greater than 0? Well, it looks like they're greater than 0 over here, but eventually they're going to be negative, so it can't be choice 2. So now we have it's between 3 or 4. If x is less than 0, then y is less than 0. And you have to remember what less than and greater than are. So if you see something that looks like a crooked L, that's less than. If it doesn't look like an L at all, it's backwards, that's a greater than sign. So x is less than 0, okay, then your y value is less than 0. Well, that's not true. Look at right here. Here's where x is less than 0. Let's call this -1. And our y value is still greater than 0. So it can't be choice 3. It has to be choice 4. Let's double check. If x is greater than 0, okay, so we're over in this area right here, then your y value is also greater than 0. Well, that's true. So it has to be choice 4. All right. So this is the next one. And this is number 18. Let's see if I can see the top of this. Nope. All right, so what this question says is it says the Jameson family kept a log of the distance they traveled during a trip, as represented by the graph below. So we are looking at hours, so elapsed time in hours, and the distance they traveled in miles as our y. Okay, so during which interval was their average speed? So in this case, you have to know that average speed is the same thing as slope. Okay? So, when is the slope the greatest? When is your m value the highest number? Is it from the first to the second hour? Okay, so that would be right here. Or is it from the second hour to the fourth hour? Okay, so second to the fourth would be here. Is it from the 6th hour to the 8th hour? Or is it from the 8th hour to the 10th hour? Okay, so what we have to figure out is what is the slope of each of these lines. I mean, automatically I can eliminate, it can't be from the 8th to the 10th hour, okay, because the steeper the slope, the higher the number. So it's definitely not 8 to 10. And it doesn't appear to be from 2 to 4 either. So I'm going to eliminate that, and I think it's between either from the 1st hour to the 2nd hour or from the 6th hour to the 8th hour. So let's figure out the slope of each of these. Remember the slope formula. It's your y2 minus your y1 over your x2 minus x1. If we look from the 1st to the 2nd hour, our y1 value is 110. Okay, so we have 110 minus our y2 value, which is 40, all over our x2 value, which is 2, minus our x1 value, which is 1. Okay, so that's going to equal 70 over 1, which is just 70. Okay, so that's the slope of our 1st to 2nd hour. Now let's try to figure out the slope of the 6th to the 8th hour. And I'm running out of room. I think I can fit it. Here's from the 6th to the 8th. So our y2 value is 350 minus our y1 value, which is 230, divided by our x2 value of 8 minus our x1 value of 6. So this gives us 120 over 2, which is a slope of 60. So if 60 is the slope from 6 to 8, and 70 is the slope from 1 to 2, then we must be looking at the 1st hour to the 2nd hour. That has the highest slope, okay, the greatest average speed. So the answer would be choice 1. Okay, number 19. Christopher looked at his quiz scores shown below for the 1st and 2nd semester of his algebra class. Which statement about Christopher's performance is correct? Okay, so we have interquartile range to look at, median score, mean score, and 3rd quartile. So, if you start by finding quartile 2, the median, what you have to notice is that neither of these lists are in order. So you would have to put them all in order. So, we could do that, or what we could do first is find the mean. So to find the mean, all you have to do is add up the numbers and divide however many there are. So if I look here, if I take semester 1, okay, and I add all these numbers up, and then I'm going to divide by 1, 2, 3, 4, so I'm going to divide by 5, I'll end up with a mean score of 86.8. And remember, if you wanted to, you could type these into your list on your calculator and come up with a mean score, as well as the quartile 1, quartile 2, quartile 3, so that might be quicker for you if you have a graphing calculator. Okay, and then the mean score for semester 2, remember I have to add everything up, and in this case I have to divide by 1, 2, 3, 4, 5, 6, so 7, and I'll end up with a mean score of 87. So only one of these choices is asking for the mean. So let's see if it works. It says the mean score for semester 2, okay, here's semester 2 right here, this 87, is greater than the mean score for semester 1. Well, that's true. So it is choice 3. I don't have to find the interquartile range or quartile 1, 2, or 3. Okay, so choice 3 is the correct answer. Okay, now we're on to number 33, and